Good evening. I wanted to start a little mini series covering various aspects of some programming concepts that I don't typically see online. And today I wanted to explain a little bit about overlays inside of the NixOS ecosystem and custom Python packages. So in NixOS, it's a declarative Linux distribution. So everything is declared inside of a configuration file, and then the system matches that configuration. So your configuration is your gold standard. Today I wanted to show how you can create an overlay using Python scripts, and then NixOS will take those overlays and install those Python scripts as if they were just binary packages on the system. So on Mac, you could do a brew install git, and then you would have the git command available to you. Well, with an overlay, you can name the file anything that you want, and when the overlay gets installed, it will just be that file name on the command line. So I'll start by showing in my code editor. I'll go to overlays first, and this is a defined NixOS model here. So NixOS knows to look for overlays in this file, and it starts with default.nix. In here, I am importing an overlay file called helpers.nix, which is one directory up. Inside this helpers.nix file, I am defining two different helpers. One is for creating Node.js scripts, which will just run generic JavaScript files as binaries. And then I've got PyScript, which will run Python scripts as a binary. And then inside of my home.nix file here, I'm taking those packages and I'm saying packages here, .helpers, .pyscript, and then I'm saying start proxy. So that helpers.nix file, I am importing that pyscript module that I created in that file. And then I'm just passing in start proxy, which is looking for the file name start-proxy.py. So if we come back out to overlays and go into scripts, you can see here that I've defined start.proxy. So I wanted to walk through the functionality of this start proxy and this kill proxy here in this tutorial today to give you an idea of how Python scripts can interact with Nix, and I wanted to show off this script as well. So on my configuration, I have a need for a Socks5 proxy, and this could be to any host that I need to connect with. In my case, I will just point it to my MacBook Pro, which is on 10.10.1.173. The first thing that will happen is this start proxy script here will come through here, and I've defined a couple of functions inside my Python script, and at the top I've defined some colors and imported a few of the libraries that I want to use. The first thing here is the main function. I've got some predefined defaults here that just make things a little easier using the tool, but I've also defined the argument parser here so that you can use things like user, host, and port and retries and pass in your own overrides to the defaults. The first thing happens here is once you've defined the command, it will then start the Socks5 proxy command, and we'll go back up and look at that. Define start Socks5 proxy here takes in SSH user, SSH host, and a local port. The first thing that I do is I check to see if the host is reachable, and I retry this, how many ever times the retry is. And at the end, if I don't have a connection successful, I'll just throw a fatal error and exit the program. The next thing I check is that port already bound on the local host? And I made a quick function that will handle that process. And if it is bound already, then I just throw an error and I kick out of the function. Assuming those two things are good, I will begin the process where I define an SSH command using -d, which will bind to a local port across a remote SSH session. And this will essentially act as a Socks5 proxy. Then what I'll do is I will fork this process using popen, And I'm going to actually wait and grab the standard out and standard error. And if I detect after the command is completely started and the SSH tunnel has been established, if I figure out that I actually did get a standard error back, I will stop the program and then with a fatal, and then I'll decode that error message for the user. So enough talk of the code, let's go and look at it in action. So first we'll say start proxy, and you can see my autocomplete's already picking up host and a port number. And you can see as the proxy begins to start here, it shows a few little blips of information here colored nicely so that you can distinguish different types of information that are being output to the screen here. And it waited for the SSH connection to fully establish, checked to make sure that there were no errors, and then we responded back to the user with an affirmative. I'm going to start a couple more of these just so I have a few of them running so that you can see the next script that I'm going to show you. And these port numbers could be anything that you wanted to define, and it could be any number of hosts that you want to define it on. I'm just using the same host for the demo purpose here. Now, if we go back into our editor, I want to show you the next overlay that I created under scripts here. I've got kill proxy, and it's very similar to the last one. With this one, though, I list out all of the SSH tunnels, and I do this by running the ps-aux command, and I grab the output from that, and then I grep over all of those using if statements. And if the command contains SSH and -d, but does not contain SSHD, then what I'm going to do is I'm going to split that up into different parts. Because this is just going to be a standard process output from PS. So I take that and I break it down and I append it into an array of dictionary objects here. And you can see that I've added the PID, the port number, and the destination. So down here in the list, I just use a little bit of Python magic to dynamically create the menu, and it will look really good with ligatures enabled. Once that is finished, you can see that I call that in the main function here, and I grab that list and I grab the choice from the user. They can choose to kill all of the sessions that are currently running. They can choose a single number, or they can exit to quit the program. And you can see that I've added all of the coloring that I added in the first script so that things look nice and then parts of the scripts are distinguishable. Here I'm defining the different choices, and ultimately when I finally decide on either all or the PID, you can see that it will take us to the kill SSH tunnel definition here, which is up here. First thing is we'll try to kill the process, and if we're not able to, then we will show an error. So I want to show this program in action now. If I run kill proxy, you can see that it will grab all of the processes that are running that we currently have a successful proxy to. And it will define it, it will show the definitions of each of those inside of the nice looking table that we've defined here. And I can access each one of these based on their ID. So if I wanted to kill the proxy that's running on 1111, I would just type in 4 and enter. And you can see that it will update the table, redraw it, and show that we had a successful stop using the PID number. Also note that I don't have to include the PIN number in the table because the user doesn't need to know that. That's just for the processing in the backend. If I wanted to kill more of these, I would just go through the process here, and I'll type in exit to leave the program. That's all I wanted to show today. That's a little bit about how overlays work. That's a little bit about how my custom scripts work. So when I run those commands, as you saw with like kill proxy or start proxy, that was all pulled in by NixOS, and it's part of the Nix store now. So each of those Python scripts have now been added to the system as if it was a binary, with nothing else needed to make that wrapped around the system. A very simple process. I hope you enjoyed today's lesson, and I'll see you next time.